In Unit 1, SLT 11, we're going to be talking about reflections in the coordinate plane and the rules of how to reflect something. So now we are going to look at coordinate rules for reflecting points or shapes over certain lines of reflection. I'm going to number these to make it easier on us so we can see. So I'm going to say this is 1, 2, 3, 4, 5, and 6. So it's asking us to reflect point A over each line and record the points. So first we're going to record the point when we reflect when we reflect A over the y-axis. So if you're looking at A, when we want to reflect it over the y-axis, which is the vertical axis that goes up and down, okay, the y one. So if I reflect it, it is 3 points away from the line of reflection. So it's going to be 1, 2, 3 points away from the line of reflection there. And I'm going to label that as A1 because number 1 is the y-axis. Now I'm going to write my coordinate points. A1 is -3, 2. Now, number 2, we're going to reflect it over the x-axis. So we're still working with this A right here. Always do this one first. We're going to reflect this one over the x-axis. So if I look, it is 1, 2 away from the x-axis. So I'm going to go 1, 2 away from the x-axis here. And this is A2. So A2, the coordinate points are 3, -2. Now the next line is x equals A, but we have to choose a number for A. So I'm going to reflect this over the line x equals 2. So it's going to reflect over the line x equals 2. And let's draw that line on our graph. So go to the x-axis and go to where x equals 2. You can make a little point there and then draw a straight line through x equals 2. And that's the line of reflection we're reflecting point A over. So if A is 1 away from that line of reflection, then A prime would be 1 away on the other side. So now I have A3. That's A3. And the coordinates for that is 1, 2. Now we're going to do where y equals b. So this is typed wrong on your paper, but if you could just fix that to y equals b. And we're going to pick a y coordinate to do. So let's do y equals 4. And we're going to go to the y-axis and plot where y equals 4. So go 1, 2, 3, 4 right here. And you're going to draw a straight line, horizontal line through y equals 4. Now we are reflecting our point A over that line of reflection. So if it's 1, 2 away from that line of reflection, then we're going to go 1, 2 away from the line of reflection up there. So now we have A4, and A4 is 3, 6. Our next line is the line y equals x, and we know that that line is the diagonal line that goes through the origin, and the origin is just that middle point right there. And when we have this line, we look and see that A, it's one away horizontally and one away vertically. So if I do the same thing on the other side, it would be right here. It's the same distance away. That would be A5 and A5. Those points are 2, 3. 2, 3. Okay. And lastly, we have y equals negative x. So this line goes through the origin, but this way. And if we look at A, it's 1, 2.5 away this way. So here it's going to be a half, 1, 2. It gets kind of confusing with all of these lines. So a trick you can do is fold your paper on this line and see where this A ends up over here. And if you do that, it should end up right about here. And that is a 6. So a 6 is at point -2, -3. So now we're going to look at how we got to these points from our original point here. So if we look at our reflection over the y-axis, our original point was 3, 2, and it went to -3, 2. So our rule here, for any time we flip something or reflect something over the y-axis, that our x and y will go to -x, and the y stays the same. So if you look, our x turned opposite or negative, and our y stayed the same. So now if we look at our x-axis, we started with 3, 2, and it went to 3, -2. So that means our xy went to x, stayed the same, and y became negative. Next is our reflection over the line x equals a. So our x was, what was it? It was 2. So when our x equaled 2, it went from 3, 2 to 1, 2. So if we look, our x, y went to, so our y stayed the same, but look what happened to our x. It went from 3 to 1. So what actually happened, our x subtracted the a, x minus a, was what we got for our x value. And when we did the reflection over the y equals b line, our y equaled 4, and our 0.32 went to 3.6. So our xy went to, x stayed the same, and the y got added on, the b got added on to the y. So if you can see, it went from 2 to 6 because we added that 4, our b. Now I want you to watch these two and make sure that that rule always works. For the next one, the reflection of y over the line y equals x, that was over the diagonal line. Our points went from 3, 2 to 2, 3. So what happened was our xy went to yx. Okay, they flipped. 3, 2 became 2, 3. And then with our reflection over the line y equals negative x, our coordinates 3, 2 went to -2, -3. So not only did they switch the x and y, but they became negative. Something to keep in mind, which is super important, is that when we have these negatives here, and here, and here, that doesn't necessarily mean that it's going to be a negative number. The negative sign in this rule, it more means that the number is going to be the opposite sign of whatever it is. So, for example, if I said xy went to negative xy, and my xy was -3 and 2, this would actually become +3, 2, because this negative, this x was already negative, so this negative sign means the opposite of x. So that's why it's +3. Now I want you to get the practice paper for SLT 11 and show me when you're done this so I can give you classwork points for it.